So we're here with Tristan Guillot of the Observatoire de la Côte d'Azur at Nice Observatory, just on the hilltop outside of Nice, and he's standing in front of a mobile of Jupiter and the four Galilean moons. And Tristan is an old friend. We first met 25 years ago during the research of my book, Distant Wanderers, on the hunt for extrasolar planets. And I came into his office, and unbeknownst to me, he had a copy of my book on the shelf. I didn't plant that, I assure you. But we've been chatting today, and he has been researching gas giant planets for over 2 decades and doing models of gas giants, working with the Juno mission here, and also with the Antarctic. An Antarctic survey being done by the French at the Dome C at Concordia Station, Antarctica. And it's called ASTEP, is that right?
Absolutely, yes. Antarctic Search for Extrasolar Planets.
And it's still ongoing. It's been ongoing since 2008. So what, after all this time, how do the gas giants, how do you think they affected life here on Earth? And is there, what can we say after 25 years of studying extrasolar planets? And when we first started off, we were only looking at hot Jupiters, these tiny half Jupiter mass planets which were on very short orbits of their suns. And today we know that there are almost, 5,000 confirmed planets, 5,000 confirmed extrasolar systems. Of the 5,000, how many resemble our own solar system? Not just with an Earth-like planet, because we really haven't found Earth 2.0, but how many resemble dynamically or compositionally anything like our own solar system?
Yeah, that's a good question. Thanks, Bruce. And it's interesting to think we've come a long way. I mean, since we first met, and 51 Peg had just been discovered, and indeed a lot has been going on in the field. I'm not sure we can actually still answer this question. How typical is the solar system? What we've discovered is that there's a huge diversity of exoplanetary systems, like 51 Peg, but other ones, for example, systems in which you have small size planets, small mass planets, but with these huge hydrogen atmospheres. So maybe they resemble a little bit these gas giant planets, but they're very small mass. And we don't know how they came to be, actually. And I believe that gas giants are really important to study because, in our solar system they had a tremendous role for the formation of the whole solar system, and we can also learn from their composition about the formation of these planetary systems. So for now we haven't found a system that's exactly like our own. We have generally systems in which planets are on more eccentric orbits. We have systems in which we have giant planets very close in. We have systems in which we have multiple small-sized planets that are very packed near to their star. And we have to learn how all these systems came to be formed and evolved. And so that's a whole field that's really expanding, and I'm really very happy to be working in that field and to see all the progress we've made in the past 25 years. But still, there's quite a lot to be done.
And you actually are advocating for a orbital mission of Neptune. You think that's what we should do next?
Yes, actually, of course, we have to continue studying exoplanets, and there are wonderful missions that are coming about, JWST, then in Europe, Plato and IL. But I believe that we also have to study our solar system because we can get very precise information on these planets. Their clouds, there's a lot of things where we don't understand. And Uranus and Neptune have never been visited by an orbiter. They've only been visited by Voyager 2, that was in 1986 and 1989, and it was only a flyby, so we only have distant images. We don't have the kind of measurements that we would need to fully understand these planets and to make the connection between what we know of a planet like Jupiter, for example, and what we're discovering on exoplanets, for which we have a lot of information, but mostly those are points in the sky, and we have statistical information. We're going to have spectra that will get better and better, but still we don't have, we're not able to observe their surfaces, their clouds, etc. So there's a lot to be done on both sides, both the exoplanets and the solar system planets.
Well, thank you again. Always a pleasure to visit the Nice Observatory, and it's great to see you again.
Well, thanks a lot.